All right, so the first assignment we're going to deal today with is evaluating logarithms. A logarithm is the inverse of an exponential equation. All right, so in other words, we usually know that 6 squared is 36, right? So in this equation, we're saying 6 to the second power equals 36. When we do a logarithm, we're working it backwards. We're saying 6 to some power equals 36. What is the exponent? In this case, it would be 2. All right, so we're just reworking this equation. We're rearranging it. So when we're finding a logarithm, what we're actually doing is finding an exponent that makes our logarithm work. All right, just some vocab here. This is called the base, right? Much in the same way that 6 in this equation is the base, right? The base is 6. The base is 6. Let's do another one. Right, in this one, we're going to try to figure out, all right, 8 is the base. So 8 to some exponent is 512. All right, so you could use a calculator to kind of guess and check if you wanted. We know 8 to the first is 8. 8 squared is 64. If we take that times 8 one more time, guess what we get, right? We get 512. So our answer again is the exponent. All right, easy enough. Some calculators have a log button on them, some do not. Some have a log button that has a base that is not what you'll have in your questions, and sometimes you'll have a log problem that is hard to do in your head, just like this one here. So these are advanced. Here's how you can do them on your calculator. All right, so most calculators are like this one, where the log button doesn't have a little base button. If you have a Casio calculator or some other calculators I'm not sure of, but a Casio definitely has a button that looks like this, log, with a square down there and a square here. And you can simply just type it in, and that's fine with me, right? What you'll notice on this one is the number goes from a base of 81 into a smaller number, 3. So when that happens, you're going to end up with, right, when you go from big number to small number, the exponent is going to be a fraction. That should tell us we have a fractional exponent. If you don't want to think through that, that's okay. So here's what we're going to do. We're going to use the change of base formula, which is going to be another assignment later on. And we're going to say, what's the log of 3 divided by the log of 81? And we're going to actually use a calculator to do this. So again, the way to do this, the way to remember is to say, all right, 81 is the base. The base of something is on the bottom, right? So the base goes in the basement, right? That's the way you say it. So if we go ahead and do that on a calculator, on the computer one, we're going to have to enter it this way. We're going to have to say 3 log and then divide 81 log. And then have to equals. So we get 0.25. So like I said, right, that's obviously 1/4. We're going to expect a fractional exponent as our answer. But you can use this formula for any one of these logarithms. Let's do another one. So we have 81. Log of 81 will go down here. Log of 1/27th on the top. And this is a challenge to do this without a calculator. You can do it in your head, but it's very tough. So we're going to say 1/27th, and then take the log of that, divided by 81 log. I get -3/4, right? So You can get a negative answer. For these, it's a negative because when you go from a whole number to a fraction, you should expect negative exponents. All right, now let's move on. Let's go check out this assignment here. Use the properties of logarithms. Actually, no, let's do this relationship between. So remember, exponentials and logarithms are inverses of each other. That's important to remember, right? So inverses work like this. If I take a look at this point here on the graph, this point is at 0, 1. So 0, 1. And this is a graph of an exponential function. So what they're asking us to do is find the graph of the log with the same base. Okay, so 0, 1 will become 1, 0. That's how inverses work, right? Y becomes X and X becomes Y. So this point was 0, 1. We're going to put a point on here at 1, 0. And we're going to do the same thing. We're going to map this point, which is at 1, 3. That's another point on the graph. We're going to map it to 3, 1. We're going to change it 3, 1. Sometimes you have to kind of click over and drag it on. 3, 1. All right, the next point is at 2, 9. The inverse of 2, 9 is 9, 2. And remember, that's the relationship we're talking about. 9, 2. It's an inverse relationship. Last one is at 3, 27. So the next point will be at 27, 3. And so what you'll notice is it's almost like a reflection, right? This curve goes that way. The inverse of it goes the other way. All right, let's continue. You might see that the problem's in the form of a table. And what you're going to notice is if we look at the two different tables, one of them is an exponential, and one of them is a logarithm. The x and y coordinates will be switched. So you'll be asked to fill in this box right here. It says something gives us 8. Well, on the other graph, we see 8 is paired up with 1.292. So that's our answer there. This one will be 12. What's 12 paired up with? 1.544. Here we go. All right, so you're going to see one other kind, and it's going to be a question where they ask you to actually rewrite the equations. Here's how I do this, right? So rewrite the following equation in logarithmic form. Right now we see an exponential form. We need to change it to logarithmic. So I know I'm going to have a log. Remember that this is the base. 8 is the base. So what's the base? 8. The base for a logarithm gets written right here. All right, so the base stays the base. The next thing is we're going to have to rework the equation. So in this particular equation, if we look at what is with 8, 8 is with the 4/3 exponent. I'm going to rewrite this equation as a logarithm. So in order to do that, I have to change what goes with the 8. This is how we'd write the logarithmic form. And again, this is true because when we look at logarithms, we say the base to that power equals the number on the inside of the log. Right, it's all the same thing. But that's how we can rework through this, right? The base stays the base, and I change the relationship between the other two numbers. So I'm going to have to actually type this in this way. I'm going to do the same type of thing down here, but I'm going to go in the other order. Remember, this is the base. 5 is the base. So it's going to stay the base. But now I'm going to write it as an exponential. I'm going to rework the relationship between the other two numbers. So now, instead of 5 being with 15,625, I'm going to write 5 with 6 on this side. Should also be true, right? It should be something you can check on your own. 5 to the 6th equals 15,625. There we go. All right, let's continue on. Let's work with properties. All right, in order to use this property section, I have this little page here. We're going to zoom in. All right, so here's some examples. If we take a look at two logs that are added together, two logs added together, we multiply the two inputs, right? So log of 5 plus log of 4 becomes log of 20. Well, it would also make sense then that if they weren't added, if they were subtracted, guess what we do? We're going to divide. Kind of like the relationship between exponents, right? If you remember, if we had two exponents that were multiplied, we added them. If we had two exponents that were divided, we subtracted. If we have a situation like this down at the bottom, where they write a number out in front, that would mean literally that there are three times the number means three of these. And if we are adding three of those, remember what do we do when we add logarithms? We multiply. So now we're going to multiply it 3 times. But wait a second, that's the same thing as cubing something, right? So the shortcut really is to ignore all that stuff and say, all right, this 3 will end up here. It'll end up like log of 4 to the third. And then I can simplify 4 to the third, and I can say it's the log of 64. I don't have to type this stuff in. The way I have them written in the boxes is the way that Khan expects the answers to be written. All right, so let's do one of these. This is addition. So this is the log of 2 times 4. So I'm just going to write log 8. Do another one. Now it's subtraction. So this becomes division. Log of 6 divided by 2. That's the log of 3. Last one. Remember what I said we can do with the exponent down here? Bring the 3 up there. So this becomes log of 4 squared, which is log 16. Bingo. All right, the last assignment on here is evaluate logarithms with the change of base rule. This is exactly what we talked about earlier, right? We're going to say, let's keep this 3 on the back burner for a second. So 3 times is what we're going to do. All right, 3 times. Let's do that instead. And then when we write our formula, we're going to do log of 9. That's the base. And then log of 1/12. This is what we did at the start of the video. And we're going to use that formula to calculate our answer, right? So let's start with 1/12. Take the log of that, divided by the log of 9. That equals that number. And then the only difference between this assignment and the last assignment we did like this is we might have a number out in front. So now let's take that times 3. They ask us round our answer to the nearest thousandth. Thousandth is the third place. So we're going to say negative 3.393 on this one. And there we go. All right, so that's a crash course in logarithms. Let me know if you have any other questions. Thanks.